Hello YouTube viewers, welcome to my show Camera Tuesday. In today's episode we're going to continue our sound series, and today we're going to look at very interesting device, Zoom F6. So let's dive right into it. Now before we dive really deep into it, we have to understand what we are talking about. So we are talking about what we classify as field recorder, basically bigger version of something like this. This is classified as handy recorder. This is basically bigger brother of this. So you have something like this, which is like a hybrid between these two, but this can only accept 2 extra channel. So what we have here is basically same thing, your portable recorder extended. Basically it's much bigger. So primary thing is it's self-contained. Basically it has a battery, recording medium, everything in it, and then it allows multiple track. This is crucial. This is the reason why somebody even bothers to buy this. Let's think of it this way. Let's say you have a setup that is going around. Let's say you have 4 occupant and all that. All of them are talking and you want to record them. Again, even if you have a good handy cam, it can only record 2 channels of audio. So that is why we rely on basically field recorder. Field recorder allows you to record independently multiple tracks. Minimum field recorder starts with like 4 tracks, 6 tracks, 8 tracks, 12 tracks, whatever you have to. And these are designed as man portable. So basically whoever is doing the boom operation, basically whoever is handling that, they can carry it if they need to. They can put it down if they need to, but they can carry it. This is there is a very serious consideration about weight. So they don't make it so heavy that you can't carry it. Basically this is a weight of a heavy laptop. It is portable and it does allow independent multiple track. That's why they will always classify as, they will never say stereo 5.1. They will never say this sort of thing. They will say 6 channel, 8 channel, 9 channel. Basically each of the channel is independent. So let's say you have a scenario where you have lavalier microphone, wireless lavalier microphone, multiple of them. Each of them can be recorded independently, which means during mixing stage where your video would be collected and you will be processing it, you can do lot of good high quality audio basically mastering if you have independent track. That is why people employ this. Basically all movie scene that you see is shot on basically field, inside, basically on set. Generally this sort of thing is used. So this is field recorder. Now biggest problem with field recorder is not with field recorder, basically audio recording industry as itself, basically the hardware itself, is that microphone has very large range. Basically if you have checked my first video in the audio series, you must understand the audio range is ludicrous. We cannot even describe it as like 1, 10, 100. We have to describe it logarithmic. It's like 1, 10, million, a trillion. So that is the problem with audio. So it is very logarithmic. However, our microphone is also very good. Microphone can let's say go from 40 decibel to upwards of, let's say, 100 dB or 110 dB. So that's a lot of range. However, the problem comes right with, like, let's say it created the signal, it sent the signal. The signal goes into what we classify as pre-amplifier. Now pre-amplifier boosts the signal, whatever it is, voltage or ampere, it boosts the signal so it becomes good enough for A to D, basically analog to digital converter, and then your signal is converted into digital file. Now that pre-amplifier is the biggest problem. Even though we can make a microphone that has very long range, basically from dB scale, our preamplifier is very limited. That is why we have gain knobs. Basically tiny knobs that you see you can tweak is there because of that, because our preamplifier, no matter how good it is just very limited. So basically your microphone can record this much, basically from dB scale, your amplifier can preamplifier can only record this much. So that is why we have to move it. So if you are in a mildly loud environment, you will put it here. If you are very loud environment, you put it here. Your quiet environment, you would put it here. But your microphone, you don't have to do anything. Microphone is this big. So this is the issue. And let's say you are talking about interview or things of that nature, people talk differently, and on top of that, people many time talk different volume. Basically right now I'm talking, let's say simplify at, let's say, -6, but let's say I start breathing heavily, my audio will go to -3. Now again, if it's properly calibrated, you can handle it. But let's say I started breathing very loudly, again your problem is now my audio is clipping. Now it's at 0. The moment it reaches 0, the audio signal is basically nothing is there. 0 simply means there is no signal. So this creates a problem that even though our microphone, that this puppy can easily record it, it's not being converted properly, because microphone range, your preamplifier range. So how do we handle it? Now in professional world, before digital even came in, audio was a very crucial thing. We had tape recorders and all that. So somebody came up with the idea that what if we drop the signal before it reached to the basically recording, before it reached to the tape. So they created what we classify as analog limiter. Analog simply means it's before anything is done to the signal to convert it, it's acting on it. Basically it's working on capacitor, transistor, MOSFET and all that. It's not doing anything digital. So let's say your microphone supposed to give signal of 7 volts. It's like, okay, 7-volt signal, you started screaming, the signal became 8-volt, 9-volt. Now this circuitry will simply tone it down before it sends it to A to D. So that way you save the signal. Now this works before A to D. This is critical aspect. Many cheap recorders, specifically like Zoom H1N, has what we classify as auto level. People think this is a limiter, and of course it is a limiter. It's just a digital limiter. Basically the mic, if the signal is clipped here, it's done. The signal is clipped, the audio clip would be very useless. To make sure that audio clip does not hurt your ear, they will simply tone down the volume where audio was clipped, but it was not it will not allow you to extract information. Basically it's lost. In this scenario it's not lost because the audio was saved before it went into digital phase. That saves the sound. However, there is a tiny penalty. It does compromise the quality. Now to give you a context of this, Zoom is rarely used in movie industry. So let's say another company that is sometimes used in movie industry is Soundbite. Now Soundbites, all of the recorders generally come equipped with analog limiter. So let's say audio quality is 100. When you engage basically analog limiter, it whenever it's activated, because it won't activate every time, it will be like, okay, I'm just chilling. The moment the signal goes up, then it will calm it down. It's like, okay, you are going to loud, then it will calm it down. So during that time, during that phase, let's say somebody started shouting, during that phase you will notice the sound quality dropped a little bit. That is why people don't generally rely on this. Like, let's just put analog limiter in everything and just forget about it. They don't want to rely on it. Of course it is needed for basically generalist work, but people don't want to rely on it because it does compromise quality little bit, not too much, little bit. And there is no comparison between analog and digital is just a joke. So what are the options that people employ? That was the first option. Another simpler, cheaper option is basically dual recording. Basically what you say is you create two independent tracks. Now you will create one primary track. Basically the gain would be set, let's say right now I set my gain to 7. I will set another track with a gain of, let's say, 5 or 3, whatever. Like if I think I'm gonna have a lot of shouting and screaming, I'm gonna set safety track to be much colder. Now this sometimes in professional edition they sometimes have dual A to D. Basically one circuit would be built specifically for handling low voltage, another would be built to handle high voltage. This way they can both be masters. Basically you generally don't want to make one generic circuit. You want to deal with low voltage, and once the signal clips you simply send it a go to hot one. So that is done. However, it is pretty awesome, and you can do it to yourself right now. Basically, even if you are doing something like I am doing, where I have one mono microphone, I can employ this if you want to. I have provided the link down below, you can see it. Now many recorders like Zoom recorder or Tascam recorder comes with the function inbuilt. So you're gonna have main recording and you're gonna have backup recording. Now this works phenomenally well. However, it does come with serious consequence. You have to do what we classify as post processing. Basically I can't, like if I have to record 4 videos per day, in every time I'm recording a video, I have to put on headphones, listen to it. Okay, here the audio I clipped, okay, splice it, then take the basically backup track and place it there. It's an extra step. Now again, you may not worry too much about it. It's more than good enough for, let's say, YouTube. But let's say you are doing a movie system. Now there you may have 8 microphone recording, you may have 12 microphone recording, or you may have 30 recordings. In those sort of scenario, having backup track for every of them is just too much hassle to deal with. So it does work. This is a very good option. It does work. It's pretty awesome, and anybody can do it. Like you can do it on your DSLR and you can do it in your recorder. You can build it yourself. It's that useful. However, the fact that there is now 2 independent tracks to deal with creates a problem. Unless somebody creates a software code where it can automatically splice that. Can be done, but nobody has done it yet. But this is the issue. So what Zoom has done, Zoom is saying they have been working for 10 years behind the scene for this, and I can accept their word, because what they have done is basically they created 2 A to D. It is common in very expensive equipment. Now the reason why they want 2 independent A to D is basically if you clone one A to D, it's like, okay, we have one, let's clone it another. It won't be master, and you have to understand in audio, when the signal is analog, you have to make sure you use the perfect component. A component that is made for, let's say, high voltage will not work very well if you send it to low voltage. It's not like, okay, I can handle high, that means I can handle low. No, that's not the case. In audio, everything is very twitchy in that way. So you have to make sure you make a circuit that is for cold voltage. It will only work properly for cold voltage. If you have a signal for basically circuit for hot voltage, you will only work properly for hot voltage. So this way they create two very good basically preamplifier. Now here's the funny thing, your microphone range is this much, your preamplifier is generally clip, it's never gonna record the full audio. What they did is basically they put two of them. Now you have this much recording space, but your microphone can only do this. So that directly translates to your microphone will never clip. Now there is a physical clipping now let's say you have a microphone, you are shouting and all that, it's not gonna clip. But let's say somebody fired a gun near to it, because the decibel scale is, I told you, let's log in, is doing 130 is your, let's say your microphone's limit. 131, it's gonna basically the membrane either is gonna tear apart or physically not gonna move, because it will be like pushed so back, the spring won't be able to allow it to bounce back. So in that scenario the microphone clipped. Now generally microphone rarely clips unless it's a bad one or you are in a gun range. Other than that, there is not that much that can clip a microphone. And even in a gun range, you can buy microphone that are designed for that. Like let's say you want to record gun sound for, let's say, Call of Duty or things of that nature, there is a microphone that is specifically built that can record that kind of high decibel sound properly. So assuming that your microphone is not clipping, you cannot clip this. Now that's okay, you got the signal, you got the good signal. Now the problem is generally we employ what we call 24-bit file. Basically every camera recording or audio recorders, they are generally 24-bit. That gives you 0 to this certain amount of depth. Now they said, okay, that's good enough, but that means I have to compress the data that I'm getting. So instead of compressing the data, they said, let's say instead of using 24, let's go to 32. Now they have much more leg room. Instead of compressing the data to fit into 24-bit, they are letting the data go. So the data is directly going into 32-bit format. This is their golden goose. Now how they are doing it, that's proprietary. But if this works, that will translate into large changes into gaming, basically audio industry. No more levels. Basically you plug your microphone, that's it. You don't have to change level. Now you might be like, okay, why the heck there are this many levels in this? Basically it's a six track recorder. So these are faders. Basically this, let's say you are taking a stereo mix out of this on the spot, you need to basically let's say you have 6 people, one person is speaking, 5 are quiet, you will set all 5 to 0, and then one person who is speaking, you will record it. Then you will keep doing this. This is fader. This is for mixing purposes. It's not gonna do any mic adjustment. They don't need to. This will change industry forever, because if this works out even half as good as they are claiming, imagine this way, like you never have to worry about your microphone clipping, because the range of 32-bit file is very huge. The range of 2 different analog to digital circuit, that's completely huge. So you don't have to worry about it. Basically now they can make a recorder that can go from as low as, let's say, 30 dB to 130 dB. No person can clip that. Basically person cannot. Of course a gun can still clip it, but a person cannot. So that is amazing. Like if this works out, if this really pans out the way they are saying, it will change audio industry permanently. But like this is not a basically upgrade. Oh, now audio quality is better. This is the evolution. Basically, like how excited I was for the last video about Rode wireless Go. This is same thing. Like this is first time somebody is like, oh, our technology has upgraded a lot, because 24-bit is an ancient file standard. Let's use that. Let's use it. Now we can use it. This is like somebody sat down and it's like, okay, let's use the technology we have right now, because silicon is very cheap right now. I think the A to D would be the expensive part. The silicon that does the 32-bit compression, they will like, yeah, that's free. Don't even worry about it. So, and they even have color LCD. Finally somebody is learning that you should have color screen. Okay. Awesome thing. If this works out, this will change the basically audio landscape permanently, and once it is successful, it will trickle down to small recorder like this. Basically we'll no longer have to worry about the knob anymore. So I see a lot of interesting thing in the future, because this is Zoom's ace up in the sleeve. Basically Rode started to take competition seriously once DAT microphones started to take a little bit of market share. They released the wireless Go. Zoom is also losing the market, because like people are frankly fed up with Zoom. Basically like you're not doing anything. It's just like, yeah, we are good, that's it. We're not pushing it. Now they have pushed it so far ahead. If this works out, they will have a competitive advantage on their competitors for years. It will take anybody else like at least 1 to 2 years to figure out how the heck they are taking the 2 signal and mixing it into 32-bit file. So they have taken a very giant leap, and if it works out, it's pretty amazing for us consumer. So this was my presentation on Zoom F6. I hope you liked it, learned from it. In that case, click the like. If you didn't, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment, and leave a comment because I reply to all of them. Press subscribe, press the bell icon if you are free, and as always, thanks for watching.